we're going to learn how to calculate the area and the arc length in polar coordinates. So to start with something like this, first we start with, let's try to draw any figure. Let's say this figure. Okay, this figure. I'm required to find the area of that part in polar. Say you got a polar curve like this. So the way it works, assume this is r or f of theta or r of theta. We define the area for this shaded region to be 1/2, I'm not going to prove the formula now, 1/2 the integral of that curve r squared of theta d theta, or f squared of theta d theta, where theta changes from here, like if you shoot arrows out like that to cover the whole region. So it's going to go from alpha to beta. So alpha to beta. So this is the formula to calculate the area in polar. How about if it's not always like this, maybe like you have the curves like there, let's say, or sometimes you have two curves. You know, you have let's say a curve here and another curve there. Call this f of theta, this is g of theta. And we need to calculate this, the area of this region. So the way it works, you're going to project this from alpha to beta, and the way we set this up for area, so if we shoot an arrow out, this is the further curve from the pole. This is, the origin is called pole in polar. Let's call this, that's the one for f of theta. So then the area is going to be 1/2 the integral from alpha to beta is going to be d theta. But instead of just one of them, we take the further one and square it, minus the closer one, which hits the curve at that point, is g of theta square. So why is it that case? Because when we do it that way, the first part, which is this, is going to give us the area of the whole yellow region, the whole yellow. And then minus the g will give me the area of the blue one. So if you take the yellow minus the blue, it gives me the black shading. Find the area of the region enclosed or bounded by the graph of r equals 3 cosine 3 theta. So if you look at the reference sheet that you have, that will tell you that's on the third row of the reference sheet, I think the second one. So you will have those roses thing. So it's going to be the first rows, the second one, and the third one. That would be the graph. So how far do we go out? This is based on the number outside. If it's 3, you go 3. So the distance from the pole to there, that's 3 units. The same thing for the other one and the other one. Like this is 3 units, 3 units. Now, what we do here, how we're going to do this, we can use symmetry to help us a lot. Okay, so the way we do it, we can find the area of just this piece, just that piece. Okay, watch how I'm gonna set this up. Just that piece. Now, how am I gonna know? So that piece, what are the bounds? That's the most important thing. Watch. It starts at 0, that's theta equals 0. 2 is gonna go all the way to theta equals some number. We don't know what that is yet. But to set this up, the formula says 1/2 the integral from 0 to some number we're gonna find in a minute. The equation that is given equation r, and you square it, d theta. Okay, so the only thing we have to worry about for now is the upper bound. To always find these upper bounds, we set r equals to 0. To set r 0. So 3 cosine 3 theta, if you set it equals 0 and divide by 3, you get this. What is the angle? It's cosine 0. It's pi over 2. That's the first angle. So 3 theta is pi over 2. So theta would be pi over 6. Pi over 6. And it makes sense graphically that this is pi over 6. So the bound goes from 0 to pi over 6. So this is pi over 6. Now that will give me only one piece. How many pieces or identical pieces are there? There's 1, 2, 3, 4, 5, 6 pieces. So we could multiply the whole thing by 6 to give me the area of all the 3 roses combined. So here we got 3 outside, 0 to pi over 6. This is 9 cosine squared 3 theta d theta. You can pull the 9 out, becomes 27, and 0 to pi over 6. Now, to work with cosine square, we give you a formula, or the recall formula. Cosine squared theta is 1 plus cosine 2 theta divided by 2. We recalled them in the previous section. But I have 3 theta instead, so you can multiply the angles by 3. So you got 1 plus cosine 6 theta over 2. So then that goes here, 1 plus cosine 6 theta divided by 2 d theta. So A is 27 over 2. The integral of 1 is theta. Plus integral of cosine 6 theta is 1 over m. Remember, 1 over 6 sine 6 theta. From 0 to pi over 6. Then we substitute the pi over 6 plus 1/6 sine pi minus 0 plus 1/6 sine 0. Sine 0 is 0. A is 27 over 2 pi over 6 plus sine pi is 0, so everything goes away. By 3/2 by 3/9. So 9 pi over 4. Let R be, let's say, 1 minus sine theta. So the graph of it, we are going to graph the heart for you, this heart, and ask you to find the area of the shaded region. Find area of shaded region. Okay, so to move on with this, we start by writing 1/2 the integral. So if I want to wipe this off, watch. So it starts at 0, theta equals 0 to where? To pi over 2. From 0 to pi over 2. And you write the equation square, which is r is 1 minus sine theta d theta. Then we're going to integrate this one. What's the integral? So keep the 1/2 as is. 0 to pi over 2. You expand this 1 minus 2 sine theta plus sine squared theta. Oh, again squared. Do you see the square? That's why we recall the formulas in the previous section. So the square of sine can be written as 1 minus cosine theta divided by 2. Then the area, keep the 1/2 out. See, here you get 1/2 and 1 is 3/2. When you integrate, you get 3/2 theta minus 2. Integral of sine is negative cosine. And then minus 1/2, integral of sine, integral of cosine is sine. 0 to pi over 2. Here we have one thing to note about 1 minus cosine 2 theta. So the cosine is a plus, the sine is minus, sine same but minus, so we have 1/2 again. Then you substitute the values in. 3 over 2 times pi over 2 plus 2 cosine pi over 2 minus 1/4 sine pi minus, put the 0 in, you're going to get 0 plus 2 cosine 0 minus 1/4 sine 0, 0. And if you simplify all of this, we get 3 pi minus 8 over 8. That's the area. How about if they ask you find the area of the region enclosed by the graph of same one, but there's no shaded region, 1 minus sine theta. So again, the graph goes down, so I need to find the area of the whole thing, of the shade of this shaded now. So what difference does that make? We have the 1/2. It's the theta what makes a difference. So if you want to start, you can start anywhere. Let's say I want to start at theta equals 0. And then I'm going to wipe this off by shooting arrows, 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 keep going, keep going, keep going, you know, like that. So basically you're going from 0 to where? To 2 pi to cover the whole thing. 0 to 2 pi. Then we have r squared d theta. 1 minus sine theta d theta. Again, you have to expand as we did before. 1 minus 2 sine theta plus sine squared theta, and replace sine squared with 1 minus cosine 2 theta over 2 and integrate the same way as the previous example, and I got 3 pi over 2. 3 pi over 2. So this is another example. Now, how can they make it a little bit more difficult? You know, like to ask you. They can ask, find the area of the region that lies outside the cardioid r equals 1 plus cosine theta, and inside the circle with the equation r equals 3 cosine theta. Not to forget to remind you, always when you work with at home on lower curves graphing, don't forget Rasmus is there available for you to use, right, to check your work, the graph. So it's cardioid that looks like a heart, right? And it's a cosine, so with a plus, so it's gonna go on the right side like that. So it's on the right side. And they said a circle, 3 cosine theta. Remember the cosine either right or left, but since it's a is 3 plus, so has to go where? To the right side. Now remember here, how far is this went out? It's 2 units because r is 1 plus 1 cosine theta. So it went out 1 plus 1, 2 units. Now the circle, in regards to the circle, A is 3. A is 3. So when we graph it, we're going to have a circle on the right side, but it's going to go out 3 units. So this would be 3 there. So they said, find the area of the region that lies outside the cardioid, but inside the circle. So they're talking about this. This region. So to find this, the most important thing, the bounds. So if you shoot the first arrow, that's gonna go here. And then it's going to keep going if you keep shooting arrows like that. All the way to the last one. So this is my alpha, that's my beta. Okay? Alpha and beta. Then the area. How do I find the area? Well, I need the bounds. Oh, so they meet at 2 points, here and there. So I need to find their point of intersection. To find their point of intersection, we set the graphs equal to each other. R equals R. So the 3 cosine theta equals the other graph, or the equation of the other graph. Subtract cosine on both sides. Divide by 2. What are the angles that cosine is 1/2, the first angle? It's pi over 3. Pi over 3. So the beta, that's our beta. The beta on the graph that you see, alpha to beta, that's pi over 3. How about the other angle? It starts in the bottom, goes up. By symmetry, alpha should be negative pi over 3. So it's going from negative pi over 3 to pi over 3. So then the area, to set up the area formula, it's 1/2 from negative pi over 3 to pi over 3. And remember how the one we gave you before, you take the further one from the pole, which is the green curve, that's for the circle, the green one. So that's 3 cosine theta, minus the one that is closer to the curve, which is 1 minus or 1 plus 1 cosine theta. So again, we take the one, the further, which is this, square minus this one square. Because when you do that, you're gonna, the first one covers the area of the whole thing, including the white and the yellow. The second one covers the white. So when you subtract the white from the whole thing, you get the yellow. That's why we subtracted. And The rest of the work is integral stuff. We have to expand, combine, and integrate. So the area becomes 1/2 negative pi over 3 to pi over 3. One thing you can do by symmetry, if you like, you can go from 0 to pi over 3 and double that. It's easier to substitute 0 rather than negative pi over 3. And here you get 9 cosine squared theta minus 1 minus 2 cosine theta minus cosine squared theta, d theta. So the area is the integral 0 to pi over 3, 8 cosine squared theta minus 2 cosine theta minus 1 d theta. And then you need to integrate this. Do you see? I'm coming across cosine square again. As I said, we use it a lot in this section. So the area is 0 to pi over 3. Here you do 1 plus cosine 2 theta over 2 minus 2 cosine theta minus 1. Now it's easy to integrate after you simplify. Then we will get all the way to a nice answer, which is pi. So find the area. Find the area outside r equals 2 and inside r equals 4 sine theta. And we will continue in the second part next time.